We've worked with word problems or application problems whenever we were dealing with equality or equations. Now we can also do the same thing when we're using inequalities. We're going to read through the problem, and that's going to tell us how to set this up. So looking at this first problem, we have 6 more than twice a number is greater than negative 14. That is greater than is our clue that this is an inequality problem. So let's start translating so that we can solve this. First of all, we have 6 more than. That means that whatever we do, we're going to have to add 6 to something. And what are we adding 6 to? Twice a number. We write that as 2x. Then next in the sentence is greater than, so we have to write our symbol. Here's where it's going to be really important that you know what those symbols are. And then negative 14. We now have an inequality statement, 2x plus 6 is greater than negative 14, that we can go ahead and solve now using all of our regular rules. So the first thing I'm going to do is subtract 6 from both sides. When we do that, now we have 2x on the left, and negative 14 minus 6 is negative 20 for the right-hand side. We did not multiply or divide by a negative, so our symbol stays the same, greater than. Now to get x alone, we have to divide both sides by 2, which will leave us with x on the left, and negative 20 divided by 2 is negative 10. Now again, we did not multiply or divide by a negative, so our symbol stays the same. Here we have a true application problem, not just a translation. This one says, Dennis and Nancy Wood are celebrating their 30th wedding anniversary by having a reception at Tiffany Oaks Reception Hall. They've budgeted $3,000 for their reception. If the reception hall charges a $50 cleanup fee plus $34 per person, find the greatest number of people that they may invite and still stay within their budget. Well, what we don't know here is the number of people that we're going to be able to invite. So let's let that be our X, or our unknown amount. Now we can start trying to translate, sort of, to create our inequality. We know that however many people that they invite, it's going to cost $34 for each person. So we would write that as 34x. And then in addition to that, they're going to have to pay a $50 cleanup fee. So we're going to have to add 50 to whatever that is. Now we cannot go over $3,000 because that's the most amount of money that we can spend. So whatever this cost is, the $50 plus the $34 a person, it has to be smaller than, or it could be equal to, $3,000 because that's what our budget is. Now we have our inequality statement and we can begin solving. So if we subtract 50 from both sides, now we have 34x on the left and 2950 on the right. We did not multiply or divide by a negative, so our symbol stays the same. Now to get x alone, we have to divide both sides by 34. So on the left we have x, and on the right we have 86.76. Now we did not multiply or divide by a negative, so our symbol stays the same. This tells us that we can invite 86.76 people. Well, when we're talking about, these types of application problems, real life type problems, we don't use our regular rounding rules. We know that we can't invite 0.76 of a person. So logically we say, well, we either have to round up or round down. Well, our normal rounding rules would say we would round this up to 87, but if we do that, now we've gone over budget. So we have to think about this in realistic terms. The only way that we can stay within our budget is if we round down to 86 people. We can't have any more than 86 people and stay within that $3,000 budget.